So we're going to do some combination and permutation examples. So the first example, we will have, let's say there are 10 men and 12 women in a pool of applicants. So we're going to talk about jobs. So just like prizes in our last example, if you remember, if everyone is getting the same prize, you could call their names all at once and they're getting the same thing. That's a combination. But if you need to call their names in an order because they're getting something different, so this would be same job, or whatever they're getting is the same, and in an order because they're getting something different, then that would be a permutation. Okay, so let's suppose there are 10 men and 12 women in a pool of applicants. 3 are going to be selected, and then I'll do different parts. We'll undo some different scenarios. So how many ways can 3 be selected for different jobs? Okay, so if they're all getting different jobs, then you need to tell them individually which job they got. So that would be in an order. You have to do them individually. Here's the first job. How many people are there altogether they're selecting from? There's not 10 or 12, there's actually 22. All right, there's 22 people. 10 are men and 12 are women. And we are selecting 3. So there's 22 people to select from for the first job. And then the second job, 21, and then 20. And again, you could say 22P3 if you wanted to. If I'm doing them in order, I'm usually just writing them out as a multiplication. And you could try this, you'll get the same thing. So that's a lot of ways. Now, if they were getting the same job, same question, how many ways can 3 be selected for the same job? Then we can't do this anymore because listing them in this order, here we don't care what order. And so if this is ABC, then CBA is the same thing here. So it's counting each one and the arrangements. Here we don't want to count the arrangements. So this is a combination, and we would say out of the 22 people, choose 3, and that will cut this down. 22C3 is 1540. And since there's 3 items, just like in our last example, this times 6 should give you that, because arranging 3 is 3 times 2 times 1, 6 ways. Okay, C. How many ways could 3 be selected if we wanted one man and 2 women? So still 3, but we want to count the number of ways to choose 1 man. So there's 10 men, so there'd be 10 ways to choose 1 man. But 2 women, there's lots of different combinations of that. Okay, in counting principles and in probability, the word and is important, and it means multiply. So anytime you would say something with and, you would mean multiply. So this is going to be a combination. We want out of the 10 men, choose 1, and that's just equal to 1. I mean 10, right? Because there was 10 to pick from. And is multiply. How many women are there in total? 12 women. So out of the 12 women, we want 2. It's It's not out of the 22 people. We want just out of the women to choose 2. 66. So this is 10 times 66, so 660 ways. What if we wanted all men or all women? Okay, if we wanted all men or all women, this would be 3 men or 3 women. And or is also an important word, and that means add. And means multiply and or means add. So we're saying this case or this one, not and, because that would be 6 people. We want 3 men or 3 women. So 3 men, how many men are there in total that we would be choosing from? 10. And we want 3. Or out of the 12 women, we want 3. $340. Okay, so that's really important. Write down exactly what you want, and if you would say the word and, you would multiply, and if you say the word or, then you would add. Okay, so that was part D. So let's say E. What if I said how many ways can at least one man be selected? Remember, there's 3 jobs. We're just talking about the same job here. So let's write the totals again. We had 10 men and 12 women, and we're selecting 3. Okay, so this is sort of the summary for the question. If we wanted at least 1 man, so at least 1 means 1 or more. So 1 man, and that would have to have 2 women because there's 3 jobs, and if 1 is a man, then 2 must be women. Or we could have 2 men and 1 woman, right? They add up to 3 jobs. Or we could have 3 men and 2 women. 0 women. And we can't have more because there's only 3 jobs. But it would be this or 2 men and 1 woman, or 3 men and 0 women. So each of these would have a multiply in them because of the and then we're going to add them up. So 1 man and 2 women, or 2 men and 1 woman, or 3 men and 0 women. So how many men are there in total? 10. We want to choose 1. And out of the 12 women, choose 2. Or is add. 10 men, choose 2, and 1 woman. So out of the 12 women, choose 1. 10 men, choose 3. 12 women, choose 0. And then we would do these 660. That number sounds familiar. I think that is the case that we did before. 1 man and 2 women. We did that one case before. Um, 12C0. if you put that in, is just one way. That's the option of not choosing anyone. There's just one way to not choose someone. And then if we add this up, we will get 12, 13, 20. Okay, now I want to show you something important, and that would be doing the complement, which is like the opposite. So there's another way we could do this same question. So we could look at the opposite. Instead of looking at what they're asking for, we could look at what the opposite is, or any other cases that we didn't consider here. The opposite, we've got 1 man, 2 men, or 3 men, so the only case that's not considered is when there's 0 men and 3 women. Out of the 10 men, 0, and is multiply. Out of the 12 women, 3. $220. I think we actually did that earlier when we did all women right here. Okay, that's the opposite. Now, how do we go from the opposite to what we actually want? We would subtract it from the total. The total minus the complement would give us what we want. Okay, so in set theory, I mean, we're not going to write it like this later, but the number in the universal set, the number in total, minus the number in the opposite is equal to the number in what we're looking for. Now, what's the total? The total is 22 people, choose 3. We did that earlier, but let's just plug it back in. 1540. So if we take 1540 is the total minus the opposite, we get 1320, which is what we were looking for. Okay, so one more example along this line. So that's E. Oh, I guess I have 2 more. Okay, so the next one. Oh, interesting. How many ways can 3 be selected for different jobs? You know, often you'll see questions maybe say president, vice president, secretary. And another 4 be selected for identical jobs. Okay, so you might have a president, VP, and secretary, and then another 4 for identical jobs. They're not talking about men and women, so we've got 22 people in total. They're not breaking them down any other way. But here we've got a sort of a mixture of just choosing 3 for different jobs. They need to be listed separately, and then these 4 could be listed all at once. So for the 3 jobs, that would have to be a permutation. And the 4 would be a combination. So let's talk about the 3 jobs first. So here's the 3 jobs, 1, 2, 3, and then this one is 4 jobs that are the same. Here's the president, VP, and secretary, and then 4 other jobs. So how many choices for president? We've got 22 people. 22 choices. Vice president, 21. We've used one up here, and then 20. And then for the remaining 4 jobs, that's a combination. What do you think it would be? How many people are left? There's 19 people left because we've used 3 of the 22, so there's 19 left, and we are choosing 4 for that. And it's president and vice president and secretary and 4 more jobs. Okay, so we would do this. Okay, so, sorry, I should show that. So 22 times 21 times 20 times 19 C4. Or you could do them separate. It's lots of ways they could be selected of 22 people. And of course you could put 22P3 here. Okay, G says suppose 7 of the applicants are to be selected for a committee. But 3 of the 22 applicants must be chosen. Let's say, we'll give them names, A, B, and C. Okay, so Abby, Bert, and Caroline are part of these 22 applicants, and they must be chosen, and then we want 4 other people. So how would we do that? So it's a committee, so they're all getting the same job, but we're separating them. Instead of men and women, we're separating them. We need all 3 of these. So let's look at it this way. There's 22 people, 3 are A, B, and C. We want all 3 of those. And then out of the 19 others, we would want 4 because there's 7 positions altogether. So we want 3 of the A, B, C, and we want 4 others. So out of the 3, choose all 3. Doesn't matter the order you choose them in, but we want all of them. And out of the 19 others, we want 4. C3 is 1. There's one way to do that. You choose all 3. 19C4. 3, 8, 7, 6 ways. So essentially we're taking these people out, and then we're saying out of the 19 others we want 4 of them for the same job. Okay, so in the next video we'll do another example.